use ranked by to do basically kind of finding people's preferences really easily. So imagine I've got watches in my database, some average watches, bad watches, and a fun watch, and they have qualities, fun, style, fun, they've numbered 1 to 9, say 1 to 9 preferences, score. They have a score of quality. So this guy scored 5 for style, 5 for quality, and 5 for fun on this watch. This bad watch had one for style, 1 for quality, and 1 for fun. And me as a user, my preference is I want to have very high quality. I don't care about this and I don't care about this. So when I match them according to my preferences, so there's me and there are my preferences, the closest watch is this one here, 853. But if I put in another watch, is say called style watch, and I'll say it's 962. Let's just see. This fun watch is actually closer numerically to my preferences than this one. But the point is, this is incredibly fast way of matching. It's called the root mean square. So basically, the closer these are to this one, then it gets ranked by the closest match. It's a very, very fast way to do preference matching. It comes from dating. So imagine I wanted to. These were numerical values of the qualities I was looking for. These would be the matches for this. And so the way this works under the covers, and I think this is what you could do to reorganize your database. Basically, for watches, I'm storing a brand like Seiko, and then I'm storing some numbers against it: the fun score, the quality score, and the style score. And I just use this as a little trick so that I'm not a watch, I'm a person, but my preferences are being stored in the same table of what my personal preferences are. So it's going to match me, as the query looks for me and then looks at all the other things in the database which look as close, root mean square, as close as they are to me. So so there's not even any workflow in this. The workflow that's here is just to me to create some stuff in the database. But the thing that is doing all that matching is as simple as, so search for watches, search for some preferences, which is not a user. So this is me hacking to say, well, I'm not a watch, I'm a user, but I want to store my preferences of my watches, and then I just go ranked by numerical similarity to, and then this is a little bit of a hack to say, look for me in the database. So there might be a more elegant way to do this, but this is an alternative way to do a much more mathematical match of watch preferences of root mean square. So this is just a suggested design of a much simpler way of ranking people's preferences to the watch qualities. It's just an idea. You can study this and have a think about it. And separately, in order to say why did I match on this one. So if I go back to here and I say, well, why did I match on this one? Well, because mathematically these numbers are closer to my numbers. And I guess you could make some inference and say, well, what you would do is for every watch, you would just go and calculate it and say which ones are in you can tell that this is a fun watch, and this is anything that was above average, you could then go and categorize. You could say, here's a fun watch, and medium quality, Let's add another one in, let's say 9 and 5. So here's another watch which has got a high score on this. So basically you could tag these watches just by mathematically saying this has a higher than average fun rating, this one has a higher than average style rating, so that you could, rather than go through and figure out why you matched on it, because we know we matched for very strongly mathematical reasons, basically we're saying, well, what are the characteristics of this watch? What make it? Well, it's got a high value for this, and this is an alternative design it would achieve the same thing. It would just be much simpler and much faster, and you could search for literally hundreds and hundreds of watches. I think it would be milliseconds.